Hi, I'm Jaychitra Jayapal. I'm going to present about effective research-based analysis on peer-to-peer network security. The analysis focused on four different things. First one is the architecture of the peer-to-peer network. Here we will see how the architecture actually differs from the traditional network what we have followed till now. And second one is the basic operations of peer-to-peer network. In that we will see what the peer-to-peer network basic operations. The third one is the possible attacks and solutions. Here we will see the list of attacks which has been encountered in the peer-to-peer network before and the possible solutions for it. The last one is the summary of the detailed presentation. Let's look into that how to peer-to-peer network differs from the traditional network. This is the example for a client-based server. In client-based server, users are connected to the server or the workstation. In order to access a file, the user needs to contact the server as the information will be stored on the server, and the server will determine who can get access to the files on the network. In the right hand side, you can see the architecture of a peer-to-peer network. As you can see, it is completely different, and you can easily notice there is no central server involved in the peer-to-peer network. The computer on the network are referred as nodes. Each node on the network connects with the other node and forms a network. Each node will act as both client and server in such a way each peer who are participating in the peer-to-peer network can able to process the request of the another peer and even send request to the another peer for file downloading or sharing. Let's look into the basic operations of peer-to-peer network. Join. The security domain administrator will authenticate a new peer to join the network. Once the peer joins the network, it can start communicate and share resources with each other. Leave. A peer has an option to leave the peer-to-peer network services by using the leave operation without informing the domain administrator. Search. When a peer starts a search query in the peer-to-peer network, the other peers who are able to receive search query can respond to it. It should also be noted only an authenticated peer can send the query throughout the network. Chat. Any peer from the group can select any other peer for communication, and they can send or receive text or voice messages from each other. Routing. The security domain administrator should be able to define and implement a routing mechanism so that only authenticated user can join the network. Insertion and retrieval. When a new peer has joined the network, the hash value for the peer has been inserted into the existing routing table. And it also been noted the hash value for any existing peer can be available for the other peer in the peer-to-peer network through the hash table. Update and delete. An authenticated peer can change the contents of the inserted resource, and they can also delete the information. Multicasting. Peers who are existing on the middle path can be able to relay the multicasting packets to the nearby peers. It also be noted only an authenticated peer can be able to participate in this kind of operations. We all know peer-to-peer network got a enormous growth in the last few years. We will look into the main reasons for it. The first main reason is no strain on server. In case of traditional network, the server will carry the desired information for the user to access, as peer-to-peer enables every peer in the network to share resources, and it avoids the strain on the server. Ideal environment. It serves as an ideal environment to share the massive number of files or folders between the other peers, free of the fear of overloading the one. No single point of failure. When the server breaks down in the traditional network, user won't be able to access any file on the network. But in case of peer-to-peer, if one of the peer is not able to deliver the service, the other peer can be able to easily replace it. much easier and less expensive to set up. As compared to the traditional network, it won't ask any expensive cost for the infrastructure. It is very easy to set up. Let's not neglect the darker side. The major disadvantage of the peer-to-peer network are it gives a chance for the malicious content to be shared and spread easily within the network as the peers are connected with each other. Malicious content can be shared and attacks can be easily made easy as the connections are made in the network. No centralized backup. Backup has to be performed on each computer separately. Since all the peers in the peer-to-peer network has resources, backup needs to be performed on each peer separately. No, make each one secure. Network security has to be applied to all the peers actively involved in the peer-to-peer network. Besides, there are a lot of security and privacy and issues surrounding around the peer-to-peer network. There are several approaches to secure peer-to-peer networks. One such is that encryption. If peer-to-peer data is encrypted, it cannot be detected easily, so attacks will be blocked. Anonymity. It can protect the identity of nodes and users on the network on anonymous P2P provides enough anonymity such that it is extremely difficult to find the source or destination of a data stream. Let's look into the possible security factors can be applied on the peer-to-peer network. First one is the user authentication. It enables to verify the authentication of the peer. It is hard to deploy in peer-to-peer than the traditional network as there is no central server to authenticate. Peer-to-peer uses keys to authenticate the user. The next one is the availability. Data should be available to the authorized user when he wants to access to it. Usability. The interface should be user-friendly so that it is easily understandable and you can change the settings according to their preference. Privacy protection. Anonymity is a feature in which identity is not revealed. Access control. Access control is a mechanism and policies that restrict access to computer resources in a process. Data integrity. It ensures that data is not changed, destroyed, or lost in an unauthorized manner. To overcome this one, digital signatures can be used. Let's look into the possible attacks. There are three types of attacks, namely attacks on peer-to-peer networks, attacks realized through peer-to-peer networks, attacks on users of peer-to-peer networks. Attacks on peer-to-peer networks are listening queries, leeches. Attacks realized through peer-to-peer networks are DDoS attack, malware spreading, poisoning of network. Attacks on users of peer-to-peer network are content verification, stealing identity. The first one is listening queries. This attack utilizes open architecture of Gnutella network. Gnutella is one of the peer-to-peer application which has the open architecture. In Gnutella network, interconnecting nodes are be able to see significant part of queries from all servers in their local subgraph. Let's see how much damage can those nodes inflict if they behave badly. Each node can be able to see crucial amount of communication which has been taking place in its subgraph. Gnutella uses 7-jump searching protocol, so every query goes through the whole network via 6 supernodes. If each supernode knows about 4 other supernodes, then it's possible for 1300 supernodes to see this query. In case of compromising a node which is able to eavesdrop the amount of queries will bring down the anonymity of Gnutella users. There are 3 methods have been provided to define anonymity in peer-to-peer networks or tunneling, broadcast encryption, friend-to-friend. Tunneling refers to the process of using of intermediate nodes to make a path between Sender and receiver. Many methods use tunneling to provide anonymity for the applications. Broadcasting encryption is a method of delivering encrypted data in the network. Only a valid user in the network can able to decrypt it. A friend-to-friend enables peer-to-peer to make direct connections with the desired peer. Password or digital signatures can be used for authentication. The next one is leeches. Leeches are refers to the peer-to-peer network clients who don't utilize administration for document sharing and they just download the information available in the peer-to-peer network. They won't share any identity with the peer-to-peer network like the active peers involved in the network. This uses contribute to an imbalance in the most peer-to-peer networks where a small percentage of users bear the majority of the sharing load. Having an imbalance creates an inefficient network with presumably slower transfer speeds than what could be possible. This can be overcome by using an administration of document sharing. A standard tool should be used for administrating the document sharing process will be a promising solution to overcome this problem. The next one is the content verification. The information what each peer is receiving in this network needs to be validated. Validity checking for the downloaded content. Each time we download a record, we should guarantee that substance of document relates to a proposed record. Malicious downloads can be very dangerous sometimes and can lead to distortion of the people at situations. This can be effectively overcome by digital signature. A digital signature refers to a mathematical technique used to validate the authenticity and integrity of a message, software, or digital document. The next one is stealing identity or data. Peer-to-peer PCs and records could be attacked by advanced users for the most part by visit administration of peer-to-peer claims. Attackers can abuse requests of these beginning users for an assistance to getting sensitive information. Monitoring tools monitor mails, files, online banking, and other applications through which access can identification information. This situation can be overcome by allowing only authenticated user can see the sensitive information. If in case of an authenticated peer behaves badly, this could be considered one serious issue. The next one is the DDoS attack. The main goal of this attack is to exhaust the victim's resources. There are two types of flooding DDoS attack: TCP connection DDoS attack and bandwidth attack. In TCP connection DDoS attack, this attack will exhaust resources by utilizing the fully open TCP connections. In bandwidth attack, the attack will be done by sending huge amount of packets to overload target's bandwidth. It can be carried out by either index poisoning or truth table poisoning. In index poisoning, attacker will insert the fake record into the peer-to-peer network. In truth table poisoning, attacker will insert the fake record into the routing table of the peer-to-peer network. Attack stimulation. Based on the research work carried by Schaffer and Malinika et al., a network of 20 virtual computers were connected to a peer-to-peer network, Direct Connect++, for this attack stimulation with DC++ hub. Direct Connect++ is an open peer-to-peer application. The ratio of active node to passive node is 20:80. Active node refers to the node with public IP address, and passive node refers to the node without a public IP address. This simulated queries attack by automatic download of non-existing file provided by the target client. This situation was achieved by deleting the shared file. The group of clients were made to sending request for the non-existing file download was created. In this situation, the target peer has responded to this query by a non-existing file error message. Findings. Based on the research carried out, DDoS attack might be unsuccessful in a small peer-to-peer network settings. As we can see, when a number of peers has been asked for the desired file which is not existing, the targeted peer replied with a non-existing file error message. But in case of a successful attack in the largest settings, it will lead to a condition of no one get any other files from the target client. It might also result in the denial of file sharing between the target client and other peers in the network. Due to the consistent failure of the targeted peer, when a peer wants to acquire data, it will lead to a situation of target peer removal from the network. The next one is the malware spreading. As the name implies, it spreads faster in the peer-to-peer network. A significant number of portrayed attacks can be joined with malware, for instance, content verification with assault utilizing malware. Research work. An empirical model was proposed by Schaffer and Malinika et al. To implement the detection systems and precautionary measures. Models in the proposed system. Model for correspondence with peer-to-peer network systems, model for download and pursuit definition, model for infection examination, module for correspondence examination, model for looking after correspondence between different models. The methodology. The proposed system for automatic file downloading from peer-to-peer network as it helps to download and analyze the files available in the peer-to-peer network. This proposed system works in a way when someone runs into some infected file while downloading a file in peer-to-peer network from a peer, this system will notice and it will start a full analysis of this file and spreads the targeted file metadata through all connected peer-to-peer networks to find out the diffusion level in this network. And then the system does this diffuses analysis regularly. This approach will also provide details regarding the number of file sharing, number of users involved, and the duration of the file in the infected users' computers. They didn't possess enough to yield the result data. The next possible solution would be trust management scheme. There are several trust management schemes which are proposed to lessen the degree of reducing the peer getting infected by downloading malicious content files. The purpose of this trust management schemes are it is based on peer reputation value. In this method, the management scheme will provide a way to assign a trust value for each peer and a file reputation value for each file which has been circulated in the peer-to-peer network. The trust value on the peer will goes on increasing if the peer giving file won't have any malicious content, and it also uses infectious value. If the peer who is going to send the file as an IN infectious value, it indirectly says the peer as most of the files with malicious value. So the trust value will go down and the infectious value will go up. So the peer with the most trust value with the lowest infectious value is the desirable peer. So whenever your peer wants to download a content from the network, the peer will choose the peer from seeing the trust value and the infectious value. And it also enables warning of the infected files throughout the network so that any peer who wants to download the file can be avoided. The models which are serving this purpose are Dynamic Trust Management Scheme, Double Layered Dynamic Trust Management Scheme, 3D Trust Management Scheme. The next one is the poisoning network. As the names imply, it means infusing pointless information into the framework. Fake things in the file could hinder query times or more regrettable yield invalid inquiries result. Poisoning can also be used as fodder for DDoS attack. This can be done in two ways, namely index poisoning or route table poisoning. As we already discussed, index poisoning refers to inserting the fake information into the index. Route table poisoning refers to the getting fake records into the route table of the peer-to-peer network. Protocol. Reliable Index Exchange Protocol was helpful in enforcing peer accountability. Gradual transition of peer to become RIEP enabled. Wang et al. Tested the RIEP defense in a peer-to-peer network over 1 million nodes and found out the effectiveness of this model. Their analysis proves that RIEP-enabled peers cannot launch index poisoning attacks on unauthorized IP address. That schemes also identifies peers who are attempting to launch the attacks. Each file index can be tracked back to publishing host without user authentication. From the overall analysis, it is clearly shown RIEP effectively reduced the attack traffic towards the victim. Let's look into the summary of the overall presentation. In this presentation, we have seen how peer-to-peer network operates on the real-time situation and its detailed infrastructure has been discussed. And like the real-time infrastructure has been discussed along with the client-based architecture. The attacks has been categorized into three ways: attacks on peer-to-peer network, attacks on relays through peer-to-peer network, attacks on users of peer-to-peer network. The attacks has been encountered in the peer-to-peer network have been addressed with the best possible research-based solution or provided along with it, and there are proposed approaches to secure peer-to-peer network. The accumulation of research result will pave a way for new questions related to the privacy of P2P network users. This work gives a way to implement the solutions in the peer-to-peer network in a real-time situations to analyze the validity of the results. I want to thank you for the opportunity provided for me to go around this topic and able to find out the different attacks and come up with the possible solutions. Thank you.